We've chosen our buffer system, the formic acid HCO2H HCO2- system, and we came up with a very specific number, and that number was a 0.182 to 1 ratio. And that is of our HCO2- to the HCO2H. And in the bigger picture, we had said in a generic system we would just label them as A- and HA. Alright, so we mentioned that there's all kinds of ratios that could get us what we need. Now we need to narrow things down. We need some constraint. And so to invent a constraint, which is what I did, I'm just going to declare, and this is totally made up, that we're going to have some objective, which is a capacity, and capacity being the moles of acid or base before it stops being a buffer in this case, so I guess I'll put it in quotes because that's not the real definition, of 10 times your increment size. Alright, so this is my made-up rule, but it gives us somewhere to start, and I think that's necessary. We have a ratio, there's an infinite number of possible directions we could go, so we're going to go with some ratio that gives us 10 times your increment size, whatever you're going to be adding of your NaOH, or sorry, yeah, of your base or acid to your buffer solution. So here are some examples of that, where maybe, for example, we have additions, so we expect 0.1 mole additions of NaOH. And that NaOH reacts with HA, in this case our formic acid, so we need 1 mole of HA. You can see I accidentally wrote HF because I'm so used to writing it. But so we have this ratio, 0.182 to 1, where we need 1 mole of HA. We know per the Henderson-Hasselbalch equation that we should have A minus over HA, in this particular case, is going to be 0.182. And so if we know that HA is 1, we can say that A minus is going to be HA times 0.182, which is unsurprisingly 0.182 if this is a 1. Alright, and that's the moles of A minus, and that would get us the ratio that we need. So a few other quick examples just working that same way. If we have 0.1 mole additions of HCl, alright? That HCl is going to react with A minus. So it's 0.1 mole additions of HCl. I'm going to need 10 times that for my A minus. So we're going to need 1 mole of A minus. When we look at this same math, we have A minus over HA as 0.182, and so our HA should be A minus over 0.182. And if we plug in that 1 in the top, it ends up 5.49 moles of HA. Alright, and those would be our molar amounts to achieve that ratio. And I do want to set up a couple more, but again, what's the idea here? The idea here is there's an infinite number of solutions to this. We can pick any combination that gives us that ratio. So I'm going to insert this constraint. I'm going to limit us to, or I'm going to cap it out at 10 times our increment size, whatever we're going to add to this buffer solution. So if I'm expecting that my increments are going to be 0.1 moles of base, I'm going to need to make sure that my HA has 1 mole, 10 times that. I'm going to just rearrange it to figure out how much A minus I have, right? We're taking an equation that has 2 unknowns, and then we are choosing one to solve for the other one. In this case, it's the HCl that we're adding, so we're going to need 1 mole of A minus. And I'll try and squeeze these other 2 on here, just so we can fit it on the same page. So let's say we're expecting 0.025 mole NaOH additions. Would have been smart for different color coding, but that's life. So The NaOH we've already established is going to react with the HA. 10 times that would be 0.25 moles of HA that we need. And so we plug in this exact same way. Our A minus is going to be HA times 0.182, and that gives us 0.0455 moles of A minus. And that gives us the ratio that we're looking for there if this is our incremental addition. And then one last one, just so we have a rounded out set of examples here. We'll say 0.015 mole additions of HCl. And that, I know I'm running out of space here. And that means we're going to need 10 times that, which is 0.15 moles of A minus. The HCl is going to react with the A minus. So we use the same math that we had used here. Our HA is going to be the A minus over 0.182. And we end up with 0.824 moles of HA. All right. And so, not super beautiful to do this, but for that particular one, we need that combination. So I can have a 1 to 0.1, well, 0.182 to 1, a 1 to 5.49, a 0.0455 to 0.25, a 0.15 to 0.824, and all of those are 0.182 to 1 ratio. Any of them will work. You're just constrained by your capacity. And again, I made that rule up for that. So knowing that, working with our 3 buffer, I'm going to continue on to the next page with the specifics of what we'll choose. After those previous examples where we looked at different amounts of A minus and HA that would give us that 0.182 ratio, and we based that on 10 times our incremental values, we're just going to declare that our application in this case requires 0.05 mole additions of HCl or NaOH. And it's important to note that the HCl would react with the formate ion, so that means I would need 0.5 moles of the HCO2 minus, or 0.5 moles of the HCO2H. Now, since we proportionally need a lot more of the HA, I'm going to work on this 0.5 right here. And you'd see, if we did some quick math, I'm going to base this on that 0.5 right there. Using that same math from moments ago, we know that A minus over HA, and again, just to save us some writing, that's our HA, and that's our A minus. Our A minus over HA needs to be 0.182, and if I choose my A minus as 0.5, I can get my HA amount as A minus over 0.182, and since that A minus is 0.5, we end up with 2.75 moles of HCO2H. All right? And now we have our recipe, 0.5 moles of HCO2 minus with 2.75 moles of HCO2H. That is our recipe. And the question is, how do I get that stuff? So to be clear in terms of what we've done so far, we picked our acid using the target pH and our increment sizes. We picked our molar amounts that we're going to start with of our formic acid and our formate. And now we're going to look at how to prepare it, which is, I think, a big hurdle for a lot of people. It happens to be a really important skill that sometimes gets skimped on in college. So now let's talk about preparation. And we're just going to use some kind of standard laboratory items that you might have. In this particular case, we'll say 6 molar formic acid and solid sodium formate. And I want to point out that there's a few different ways to do this.